Seismic wavelet phase stability is an important consideration, particularly when interpreting subtle reflection anomalies. At OGS, we have a method for identifying and correcting spatial phase variations. The procedure requires the seismic data along with horizon control for the dominant reflections in the geological column. The horizons allow us to examine piecewise windows of reflectivity in a way that follows the general structure of main reflections. For each window, we investigate waveform phase characteristics at each bin location within the survey area. Waveform phase changes from bin to bin give us an indication of relative spatial phase drift. For any one single analysis window, it is impossible to separate out the phase effects that are due to local geological interference from the phase effects due to variations in the source wavelet. But when we examine the information across multiple analysis windows, we can uncouple the spatial variations associated with the source wavelet. We do this by identifying the portion of the phase drift that is consistent from window to window. In other words, the portion that is irrespective of the local geological interference within any single window. If this source wavelet portion is significant enough to require attention, as it is in this land data example that's targeting the Bakken, it is smoothed, then removed by applying a counteractive spatially variant phase rotation. Since this procedure removes only that which affects all the analysis windows, it does not remove locally present tuning-induced phasing that is present in any single window. Once the correction is applied, the steps are repeated to determine if the correction was effective. The multi-window phase map after the second go-around, as shown here, should be free of significant phase drift. Additional forms of QC include the examination of cross-sections for evidence of improved spatial consistency and waveform character, and also ties to well control for measures of absolute phase. In the example shown here, the spatially variant phase correction led to a more consistent seismic to well phase tie.